Hello, my name is Ilker Boz. I'm a research scientist at Virginia Transportation Research Council, a research division of Virginia Department of Transportation. Today I'm going to cover a presentation on a test method that is used to evaluate resistance of asphalt mixture against moisture-induced damage, also known as a TSR test. VDOT-Spec 211 requires moisture damage test or TSR test to be performed in accordance with AASHTO T283. A standard method of test for resistance of compacted asphalt mixture to moisture-induced damage. Scope of this test includes procedures for preparing and testing of asphalt mixtures, as well as measurement of change in indirect tensile strength of asphalt mixtures resulting from effects of water saturation and accelerated water conditioning with a freeze-thaw cycle. This method is intended to evaluate the effects of saturation and accelerated water conditioning or moisture damage effect of asphalt mixtures. As I indicated, VDOT requires this test as part of balanced mix design process, as referred in Spec 211, during mix design and production. And for production, it's only for the first production lot, the testing that required for this test. Apparatus, there are a list of apparatus in the spec. Probably you would need more than these to perform this test, but those are main apparatus that every lab should have. And main thing in here, loading equipment and still loading strip that is needed to actually perform the test. The rest is about specimen preparation. One thing that I want to add that is of importance here, standard refers to two different dimensions, 4-inch and 6-inch diameter specimens. But when using 6-inch, please make sure that you are using the right loading strip as shown in this figure here. As part of the testing, VDOT only requires testing of laboratory mix and laboratory compacted and field mix or plant mix laboratory compacted specimens. And you can see the dimensions here for Marshall Hammer and gyratory compactor specimens. I should note that spec refers to a height of 88.9 plus minus 5.1 millimeter, but that could be a typo. Typically, AASHTO standard refers to 95 millimeter tall specimens. Specimen preparation and conditioning. As part of this test, at least 6 specimens are required, half to be tested in dry condition and other half to be tested in wet condition. In other words, after going through partial saturation and moisture conditioning with a freeze-thaw cycle. For lab mix and lab compacted specimens, that is for your design testing, you would place the mixture into oven for 2 hours plus minus 10 minutes at the compaction temperature prior to compaction. For field mix and lab compacted specimens, place this mixture in an oven until it reaches the compaction temperature. AASHTO spec has a curing period indicated, but VDOT spec waives that curing period. So there's no curing period with TSR testing following AASHTO spec, following VDOT spec 211. And the specimens to be compacted to 7 plus minus 0.5% air voids in this procedure. After cooling, you need to determine the percent of air voids in your specimens following AASHTO 269. And then once that's done, you have to separate the specimen into subsets, 2 subsets, 3 to be tested dry, 3 to be tested in wet condition. Of course, the air voids should be on average equal to between each subsets. And then one subset has to go through the conditioning process as indicated in AASHTO 283, and details are listed here. So specimens have to be saturated between 70 and 80%. Following that, specimens have to be put in a freezer at a temperature of minus 18 for a minimum of 16 hours. Once that's done, specimens then need to be transferred to a water bath at a 60 C for 20 hours. And prior to the test, both sets have to be placed into a water bath for 2 hours at a temperature of 25 C. And it should be noted that specimens have to be submerged underwater. Testing procedure. Before you proceed with testing, please inspect that the fixture is clean, all contact surfaces clean and free of debris. And then install the specimens into the fixture, ensuring that it's centered and making uniform contact with the loading strip. And then perform the testing at 25 C with a loading rate of 50 millimeter per minute. Calculations of strength parameter. Depending on the units that you use, here are the equations. Basically, once you have the test done, extract load versus displacement curve, calculate the peak load or determine the peak load from that curve, and then you have your specimen thickness and diameter also determined, and then just plug in the numbers and solve for that equation to determine your strength for your dry set or unconditioned set and for your wet set or conditioned set. And then once you have your strength value calculated, then you are going to determine the tensile strength ratio, which is ratio of conditioned subset to strength of the dry subset. Once you calculate that, you would check your TSR against pre.spec criterion, which is 80% in this case. If your TSR value is less than 80%, which means your mix is failing and susceptible to moisture damage. If your TSR is 80% or higher, you have a passing mix, which indicates that it will be moisture resistance in the field. There is no currently available precision estimates and statements for this test, and that would be it. So thank you for listening. If you have any questions, please email me at ilker.boss@vdot.virginia.gov.